All right, guys, we left off talking about patterns in the periodic table, and on the back side of your coloring page, there's a table that looks a lot like this one there for you to fill out as we go through a couple of these here. I'm going to try and get through this quickly, but not race through it. There's some things I wish I was there. We'd talk about a few more things, but a few things I want to show you, and a couple of things I want to talk to you about. So we talked in class about the pattern for valence electrons. And we said that we start off on the left side of the periodic table with one valence electron, and then we add one more valence electron with each family that we step over to the right. This is a 3D printout of a project I used to have students do in the very class that you're in, and you can see this is a periodic table. It's the main group of the periodic table, and that first row where hydrogen is at the top here is short, and then they get a little taller in each row. It's like a staircase, and that shows the valence electrons pattern. Start with 1, then we get 2, skip over the transition metals in the middle, 3, 4, 5, 6, 7, and then 8 for the noble gases, except for helium. Helium only has 2 because its first level is filled up with 2. That's the pattern with valence electrons. Everybody in the same family has the same number of valence electrons. If we look at a graph of the atomic mass of the first 30-some elements, it would look like this. And this looks pretty boring, actually, unless I divide it up for you a bit. So let me divide it into chunks for you. The red box here is the atomic mass of the first row of the periodic table, the first period, and then the orange one would be the second period, and then we have the third period in green and the fourth period in blue. And you can see that in each row, the mass gets bigger and bigger as we go across the table from left to right. In this model, you can sort of see that. So in each row, so in the first row, it's a little tough to tell, there's only 2 of them, but in the second row, maybe you can see if I hold it this way, they get taller and taller and taller. And in the third row, they get taller and taller and taller. The mass increases as we go from left to right. So on your chart for the period pattern, left to right pattern, say mass gets bigger going to the right, bigger going to the right, okay? And then for the family pattern, that's a little tough to see in a graph like this. Let me highlight for you the members of the same family. That very first family, starting with hydrogen here, element number 1, and then lithium and sodium and potassium. These are the 4 members of that family. As we go down in the family from element number 1 to the next one down, to the next one down, to the next one down, we can see the mass gets bigger as we go down. And you can kind of see that in this example as well. The mass gets larger as I step down each row in this periodic table. I'll leave these examples out on my front table for you. You can have a look at them if you would like. Okay, so if we go back to this is the halogens, for example, we can see that as we go down the halogen family, the mass gets bigger. This is a picture of the drawing that made that printout right there, and you can see as we go down in a family, the mass gets bigger, and as we go across from the left side of the table to the right side of the table, the mass gets bigger. So bigger going to the right and bigger going down. The radius of atoms, how big they are, their size also has a pattern. So if I graph, again, the atomic number, so this is hydrogen and then helium, and we go across all the way out to the 30th some element, we get a graph that looks like this. It's kind of interesting if I break it up by row. And when we can see that there is a repeating pattern here, we can see that on the left side of the row, the atomic radius is pretty big, and the atoms actually get smaller as we go to the right, which is not what you probably would have guessed just a minute ago. So as I go across from lithium, and then I go to beryllium and boron and carbon and nitrogen and oxygen, across to the right side of the table, you actually end up getting smaller. And we see that happen again in the next row and in the next row. Let's see if I can find my example here. Atomic radius table is this one right here. Atoms actually get littler as we go across to the right. Even though the numbers are getting bigger, the atoms, the size, their radius is getting smaller. Within families, so if I look at the first family, we can see though that going from hydrogen to lithium to sodium to potassium, they're actually getting bigger and bigger and bigger. So as we go down in a family, they get larger. This is an interesting pattern. If you look at the neighbors, the alkaline earth metals, we see that they are going from here up to there. It's a little increase and then an increase there. They get larger as we go down. Here's what this table looks like. And again, this would be hydrogen up here. Helium is the one that's right in your face here. As I go down in helium's family, atoms get bigger. But you can see as I come across from the left side of the table to the right side of the table, the atoms actually get smaller. So the atomic radius pattern is smaller going to the right and bigger going down. Density is one that does not have a super great pattern, and there's some complicating things here. It depends on the temperature at which you measure the densities, and so we're going to say that this is not a super distinct pattern. But in general, atoms get more dense as we go across from left to right in a family. We can see that in each of those rows, and they also get more dense as we go down in. I should say they get more dense as we go left to right across a period, and also more dense as we go down. I think I've got a density one here, maybe. I don't think, actually it looks like, as I look at it now, I don't think I do. This is not a great pattern, so I don't think I made one for this. Your pattern for density is bigger going to the right and bigger going down, similar to the pattern for atomic mass, okay? The last one we're gonna look at is what's called first ionization energy. That's how difficult it is to steal an electron away from an atom, to change an atom into an ion, ionization energy, okay? So first ionization energy, the graph looks like this, and that's, you can see, look like a sawtooth pattern here. It gets bigger and bigger, it gets small. When we start the next row, it gets bigger and bigger and bigger in that row, and then it gets smaller again at the start of the next row, and bigger and bigger and bigger, and then smaller again as we start the next row. So as we go left to right across a row, a period, the atoms get a higher first ionization energy. And then what happens as we go down in a family? We can see that from hydrogen to lithium to sodium to potassium, in this first family on the periodic table, we start off with a big first ionization energy, and it gets smaller as we go down in the family. And we can see that again also if we look at the noble gases, we have a big first ionization energy for helium, and it gets a little less as we step down in that family. They get smaller as we go down. Here's a picture of that drawing. Hydrogen to lithium, and as we go down to sodium, it gets smaller and smaller. As we go across to the right, it gets larger, but as we go down in a family, it gets smaller. So as we go to the right, it gets bigger, and it gets smaller as we go down. Hope this is helpful. Get this written down. This is going to be on your quizzes and on your tests, which are coming up very soon. This also will help you to get an idea of what a periodic pattern is like, the possibilities for one, so that when you make your periodic table of whatever, you have a better idea about what a periodic pattern even is. Hope this is helpful. I hope you got it written down, and we'll see you when I get home.